Hey, today we're going to talk about fire. Yes, fire, everybody's favorite topic. So today we're going to talk about the chemical equation called combustion, which is responsible for fire. We're going to start off today by talking about what actually is happening during a fire, and then the fire we're talking about today is going to be caused by hydrocarbons. Hydrocarbons such as gasoline, diesel fuel, propane, butane, those things are all made of two elements. They're made of carbon, if you look over here to the side, carbon and also of hydrogen. So now the combinations of carbon and hydrogen what make the different fuels. This first one, CH4, is known as methane gas, and methane or natural gas is what people use in town to cook on. If you have natural gas at home, or if you have a natural gas furnace, that's what they have. Now they send natural gas through a pipeline to your house, and that's one thing that we use. Down here, C3H8, that's propane, and propane is what we use for grilling. Some people out in the country have a giant propane tank that they use to heat their house. I use one to heat my greenhouse, right? So propane is C3H8. Butane, C4H10 down here, butane, that's what's in those little big lighters, right? The little plastic lighters that you can see the liquid inside, right? So those are the fuels. Now, it can go as many as, well, it's almost unlimited how many carbons you can have in this chain with hydrogens attached. Some other products that also go through the combustion we're talking about could also have an oxygen in there. So things like ethers or alcohols are also very combustible, which means that they can burn. And what actually combustion is when it combines with one of our most popular elements with oxygen, O2. Now, oxygen is O2 because oxygen is one of those 7 elements that can never be alone. So when it's by itself, like elemental-wise, it has to be O2, oxygen. Okay, and so the fuel, the hydrocarbon, which means carbon and hydrogen, the hydrocarbon reacts with the oxygen, and it forms two products. Those two products are the same every time in today's. It could burn other things in there and have impurities, but today we're talking about a nice clean combustion, and it'll form carbon dioxide, the same gas that you breathe out, and water vapor. So it's going to take those things and form carbon dioxide and water vapor. Now, a lot of you guys have heard of carbon monoxide, which would be just CO. That comes from incomplete combustion. If there's not enough oxygen around and it burns, which in every burning situation almost, this is going to happen, right? It's trying to react as fast as it can. You have to supply the oxygen to it as quickly as possible. If there's incomplete combustion, it makes this carbon monoxide. And carbon monoxide is a poisonous gas that it suffocates you. It's like my one friend at his house, that they had a leaky furnace. I mean, the exhaust was leaking somehow, and he woke up in the middle of the night and he had a really, really bad headache, and I don't know how he realized this, but his whole family was brutal. He couldn't wake his wife up. He had to carry her outside into the fresh air. Carbon monoxide, it clings to your hemoglobin, which is in your blood, the red blood cells, and it is more reactive than just oxygen by itself, and so it takes the place on your red blood cell where the oxygen's supposed to go. And so in your body, when you breathe in the air, even if there's oxygen mixed with that, the carbon monoxide is going to take that spot and hold on to it. And it just holds on to that red blood cell. And so when the red blood cell goes around your body delivering oxygen like it's supposed to, that carbon monoxide still doesn't let go. And it won't let go. It doesn't give any oxygen to the cell, and then it makes its way back around again. And it maybe another carbon monoxide joins to it. I forget how many can actually join onto one. But it fills up the space, so your body's not getting the oxygen where it needs. And the headaches, dizziness, being tired, all comes from lack of O2 to the brain. Okay, anyway, that's beside the point. Let's talk about balancing these equations. So today we're going to balance these equations. Now, balancing equations for combustion can be a little tricky. I have a pattern. Follow this pattern. All right? This pattern is going to fix problems that can occur later. And the problem that can occur is because of this O2 here, right? It messes up if we have an odd number on the right and we have O2, well, that throws a whole monkey wrench in the system. We can't finish it, right? So we're going to fix that problem with one simple solution. We're going to put a 2. I'm going to sneeze, I think. No, maybe not. We're going to put a 2 in front of this. 2 in front of that nice little... I'm not on the top one anymore. Let me go to the top one. I don't want someone to start in the wrong spot. Okay, so we'll put a 2 in front right here. Put a 2 right there. Okay. Now, what that did was solve any problems with odd numbers later. All right, let's take care of this right now. So now we have 2 C's. So we need to put a 2 in front of the carbon dioxide. Okay, so let's write down our rules, what we're going to do. We're going to put 2, where's it at? There it is, okay. My first one was behind my picture. So we're going to put a 2 in front of the C's and the H's. Right? We're going to balance the C's first, right? Get them out of the way. Get those C's out of the way. Then we're going to go right to the H's and balance the H's. So look what we have. We have 2 and 4, 2 and 4, 2 and 4, 2 and 4. That's 8. So we're going to put something equal to 8 here, 4 and 2. Right? We have to make sure when they multiply the subscript to the coefficient, that's the small number to the big number, it equals the same amount on both sides. Okay. Now, once we get the C's and the H's out of the way, we're going to deal with the oxygens. Oh, what happened there? Sorry about that. So balance the H's. And the last thing we're going to do is balance the oxygens. And the reason we're doing oxygens last is because the oxygens are on both compounds on this side, right? We don't want what happens if you were to balance the C's or the H's after the O's? That would change the number of O's. So we're going to save the O's till the end. All right, here we go. So O's, we have to do both things. So we have 2 times 2, which is 4. So we have 4 O's, and I'm going to write it below this. We have 4 O's right there. That's not a 40, that's 4 oxygens. And then we have 4 times 1. Right? 4 and 1 here. So we have 4 oxygens here. I'm just going to take the symbol off. Okay, so we have 4 and 4. So 4 and 4, we add those together, and that equals 8. All right, so we have 8 oxygens on the right, and we need to have 8 on the left. So what times 2 equals 8? And that would be 4. Okay? Now, one thing that a lot of teachers want you to do is reduce these down in the equation. If they're all the same, if they're all even numbers like 2, 4, 2, 4, you can reduce that down. What I'm going to do for you guys is because that won't affect us in a later problems that we're going to do with these. So we're just going to leave it like that. Now, if you want to reduce it or you don't put the 2 in front of it first and it ends up being smaller, that's fine. As long as the ratios of the elements are correct, that's all I'm going to worry about for you guys. Okay? Let's try number 2. Again, follow our pattern down here. Put a 2 in front. You know what you should do? Just put a 2 in front of all these. Let's do these 3 at a time. How's that sound? 3 at a time. Okay, 2, 2, 2. Okay, now what do we do next? We got to balance those C's. All right, you know what I'll do? I'll highlight them in the same color that I'm doing it. So I'll do this in pink. Where is the pink? There it is. Okay, so let's balance these C's first. We have 2 times 2. 2 times 2 is 4. So we need, this is a 1, so 4 times 1 equals 4. Okay, let's do the next one below it. 2 times 3 is 6, so there's a 1 there. So 6 times 1 equals 6. So they're going to add up to whatever the C's are, right? Here's 2 times 4, that's 8. So there's a 1 there, so this is going to be 8. See how that works? All right. Halfway done with those. Halfway done with those 3. Okay, now we're going to do the H's. 2 times 6 is 12. And the great part about this 2 here is that this 2, and there's a 2 here. So, right, 2 times 6 is 12. So 6 times 2 is 12. Right? It's going to be the same as the coefficient, or same as the subscript this way. 2 times 8, 8 times 2. 2 times 10, 10 times 2. And that makes it a little easier because you don't have to really do much math that way, right? The first one you multiply, and it's going to be the same number on the C's. The second one, it's going to be the same as the subscript for the H's. So it works out pretty nice. Okay, here's the part where you have to think, though. We have to add up all these O's. So we have 4 times 2, that's 8, plus 6 times 1, 6. 8 plus 6, 14. Okay. Now, we have to make it, on the other side, equal 14, right? It has to equal 14. So 2 times what equals 14? So all you have to do is divide 14 by 2, right? So 7 times 2 equals 14. Okay? 6 times 2 is 12. 8 times 1 is 8. 12 plus 8 equals 20. What times 2 equals 20? Well, 10 times 2 equals 20. All right? Last one of this that's showing here. 8 times 2 is 16. 10 times 1 is 10. That's 26. 26, okay, it has to equal 26. So we have 2 times what equals 26. If you can't do it in your head, just divide by 2. And 13 times 2 is 26. Okay, there's the first 4. That's almost half of them, right? And what we'll do, I'm going to get you started. Put a 2 here. Put a 2 here. Put a 2 here. Let's do this again, okay? I'll go faster this time. 2, 2, and 2. Okay, now let's do our C's. 2 times 5, 10. 2 times 6, 12. 2 times 2, 4. Okay? Do our H's. All right? Remember, it's going to be the same number. 2 times 12 is the same as 12 times 2. 2 times 14 is the same as 14 times 2. 2 times 4 is the same as 4 times 2. Okay. Now, add up your oxygens. All right. I'm going to do the first one, but I'm going to leave the other ones for you. And I'm going to leave that last one all to yourself, okay? So if you just watch the video up to this point, you're going to get, what is it? Is there 2 more left? Oh, there's 2 more. I'll leave the last 2 for you guys. You're going to get like 6, you're going to get over half of it right. And then the rest, you'll be able to do this. You'll be able to do it. Okay, so we have 10 times 2 is 20 plus 12. Equals 32. Ask yourself, what times 2 equals 32? Oops, my face is in the way. Whoop, there we go. All right, I'm going to take you to the next step again. 12 times 2 is 24, plus 14 equals 38. What times 2 equals 38? Okay. 4 times 2 is 8 plus 4, 12. Okay, so finish this up. All right. Last two, you're on your own. Well, put a 2 in front of these first. I'll do that for you. How's that? Okay, do the C's. You can do it right now if you want. 2 times 2. The next one, the bottom one. 2 times 6. Okay, got those? Go to the H's. Now we're on the second to the bottom one. 2 times 2, and then you have a 2 already. So you have 4 C's, and you're going to, 4 H's, and you're going to need a 1 over here to make that 4. 2 times 6, and then you're going to need what times, that equals 12, right? So what times 2 equals that, 12, all right? And I'm going to stop. Okay, good luck with those. Follow that pattern. It will make it a lot easier. You don't have to follow the pattern, but the pattern works. It makes it easier. It's the same every time. Good luck. And I've talked too long, so have a good day. Hey, don't forget to do that attendance quiz. It's super easy. You just say, hey, I watched the video, I understand. Or I watched the video, I didn't understand. Or I didn't do anything, right? If you put nothing, if you say that you didn't do anything, which at this point in the video, you wouldn't be telling the truth anyway, right? But if another day, if you pick nothing, you say, all I did was open the attendance quiz, you don't get credit for that. You have to do it. Okay, I'm done. Have a great day.